Topic is common bus system and types of buses. A computer has different functional units like CPU, main memory and input-output units. So to connect all these functional units so that they can communicate with each other and perform operations with the help of each other. So to perform the same we need a medium through which we can connect the different parts of the computer. So we can say bus is used to connect the different parts of the computer. So next we discuss about the bus. Bus is a group of wires or lines that connect different devices within a computer system, and each wire or line can transfer one bit of information. As you see in the diagram, in the bus, each wire or line can transfer one bit of information. It can be either 1 or 0. Next is bus carries data, address and control information, and there are three types of buses which are address bus, data bus and control bus. Next, the diagram is given in which the different functional units of the computers are connected within a bus. Next is architecture, in which the various functional units of the computers like CPU, memory, input-output devices, which are the peripheral devices, are connected with the different types of buses. For example, control bus, address bus and data bus, and you can see the connection between peripheral devices and between these buses. Next we discuss the different types of buses. As we discussed, we have three types of buses: address bus, data bus and control bus. So first we discuss about the address bus. Address bus, as you see in the diagram, it is unidirectional and it is a group of wires which carries address information bits from processor to peripherals, and address bus width determines the maximum memory capacity. Address bus width determines the maximum memory capacity. For example, if 16 bits are in the address bus, then it tells about the how many bits are in memory. 16 bits is equal to 2 raised to power 16 memory location available in the memory. So we can say address bus width determines the maximum memory capacity. So in general, 2 raised to power x is equal to n, where x is the number of address lines, or you can say address bit, and n is the number of location. So next we discuss about the data bus. Data bus is a bidirectional. As you see in the diagram, it is a bidirectional bus and it is a group of wires which carries data information bits from processor to peripherals and vice versa. Move data and instruction between CPU and peripherals. As you see in the diagram, our data bus is a bidirectional bus in which the instruction or data flow between the CPU, from CPU to peripheral devices and from peripherals to CPU devices. And next is data buses. Data bus width determines the system performance, or you can say word length of computer. So one word of memory location is equal to data bus size. For example, if in this example the data bus size is of 64 bits, then in the memory location it denotes the memory location which is equal to data bus size. So one word of memory location is equal to data bus size. Next is control bus. The control bus, as you see in the diagram, this is the bidirectional bus and it is a group of wires which carries control signal from processor to peripherals and vice versa, and it controls the access to and use of address lines and data lines. इट मीन्स ये कंट्रोल करती है कि जो भी हमारी एड्रेस बस है या डाटा लाइंस हैं, कौन इनको यूज़ करेगा, कैसे करेगा, कब करेगा. सो ये सारी डिटेल्स है, ये कौन कंट्रोल करता है, ये कंट्रोल करती है कंट्रोल बस. अगर इफ़ एनी एड्रेस गोइंग थ्रू द एड्रेस बस is that address for memory or input output devices. So it tells about by the control bus. So फॉर एग्ज़ाम्पल अगर हमारी कोई भी एड्रेस बस में कोई भी एड्रेस है तो क्या वो एड्रेस मेमोरी के लिए है या इनपुट आउटपुट डिवाइसेस के लिए है, तो ये सारा कौन कंट्रोल करता है, ये सारा कंट्रोल बस हमें बताता है कि वो एड्रेस कौन कैरी कर सकता है।